High-speed broadband is here, but how fast is it, and who will get it?
Broadband has been the fastest penetrating technology probably in the history of mankind.
There are about 1 billion active smartphones in use today, expected to go to 2 billion by the year 2015.
Ultra high-speed networks in and of themselves don't do anything. But the new innovation and new capabilities that these networks will allow, I think, are going to surprise all of us.
In fact, Cisco just came out with a study that said 13x increase in the amount of data over the next 5 years on top of these networks.
Some have estimated that it would take somewhere between $200 and $400 billion to fiber the entire country if we wanted to do that. That's not going to happen.
This country was built on the premise of equal opportunity. But in the new digital age, we may find ourselves behind the curve and behind our competition.
The large companies aren't using the fund to build broadband. The mid-sized carriers are basically just chasing themselves, trying to figure out what they're going to do next. And my carriers have certainly seen a disincentive.
How many Einsteins are we missing now because some guy in Elko can't connect to the internet?
It's not about internet connectivity. It's not about broadband for the sake of broadband. It's about the infrastructure that supports the applications that are going to allow a community to thrive.
We live in historic times, driven by innovation. But is technology providing real value? And how do we translate that value into our lives, our companies, our network? How do we stay connected without draining vital resources? Are we moving towards efficiency and sustainability? Or are we weakening the network? A connected world is what we strive for. It changes the world we live in every day, every minute, and sometimes every second. It's what makes our lives better. It's the future of the network. Imagine that you could get from point A to point B 100 times faster. Imagine what that would mean for your business, for your family. What if your neighbor had that ability, but you didn't? Does that put you at a disadvantage? Do we know the true impact of high-speed broadband and how it changes our everyday lives? So what is broadband?
The National Broadband Plan defines it as 4 megabits down, 1 megabit up. I think that's a little too slow.
Trying to define it by speed is kind of like trying to catch the air in your hands. It's going to always be elusive, it's going to always be wrong, it's going to always be out of date.
Broadband, probably we could have 10 people in the room and have 10 different definitions.
Broadband for the sake of broadband misses the fundamental value, and that's where confusion in the market lies. Giving an understanding of broadband as the foundation for job creation, for advanced data centers, for IP applications, supporting telemedicine, supporting distance education. That's when you start to get an understanding of, I need to be, as a medical provider, I need to participate in my state's health information exchange. I don't know what that 10 or 15 or 20 megabits business means. I'm not in the business of telecom, I'm in the business of saving lives, and I just need to make sure that my network can support our business.
But is 7 megabits per second down and 4 megabits per second up fast enough? What does that mean for typical internet use? At that speed, you can download 1 email in 1/10 of a second or 10 emails per second. Web pages load 3 per second, and a typical smartphone photo only takes 2.2 seconds to download. But as you get to HD video, with file sizes larger than 6 gigabytes, you need over 4 hours to download 1 program. But even more demanding is going to be IPTV and movies in the next few years. For consumers that want a truly immersive and theatrical experience at home, 4K TVs are already being produced in limited quantities. 4 times the resolution of our current HD televisions, 4K TV creates images that are 45 megabytes per frame. At 240,000 plus frames per movie, that makes for a 20 terabyte uncompressed video, or over 200 gigabytes when compressed down for home use. Transmit that over a typical 7 megabit connection and you'll be waiting 63 hours. 8K TV, or 16 times standard 1080p resolution, has already been successfully broadcast during the London Olympics. At 43 terabytes, the equivalent of 524,000 smartphone pictures, or 1.3 trillion emails, an average 7 megabit connection would take over 2 weeks for one movie to download. The Olympic broadcast transmitted at a speed equivalent to a 500 megabit connection. Cities like Kansas City, Kansas, and Chattanooga, Tennessee have leapt to 100 times faster than the national average internet connection with gigabit internet. Some say these gigabit cities are the path to the future of innovation. Others say it's too much, too soon.
While it may be true today that many applications and many uses can run on less than a gigabit of connectivity, as we go forward, we know that we're going to need at least 100, 400, 500, 700, and a gigabit. And from an engineering standpoint and from a cost standpoint, the difference between 20 and 30 megabits per second to 100 is a much bigger difference than it is from 100 to a gig.
100 times faster is definitely seems like a lot, especially considering that the average speeds today are 7.2 megabits download, 2 megabits upload. But what we're trying to do is future-proof people's homes and people's businesses. So we're not just worried about what's going to happen next year or the year after that. We're worrying about what's going to happen 10, 15, 20 years from now.
Even if we don't yet know what the applications are, the people at Google have looked at what has happened in the past and understand that every time you've made a leap of bandwidth, you have had a corresponding leap in the applications. So they're pushing it hard. They're essentially goosing the industry forward.
The average person in school even is probably not going to need a gigabit. Though in a year or two they could probably find a bunch of things to do with it and be very happy campers, but it's not necessarily what they absolutely need. But if I am going to have, like I said, several hundred or several thousand kids accessing the latest technology, then either I have broadband, I have enough capacity and speed, or all I have is just internet access.
A lot of home-based businesses are dealing with a lot of data. And sometimes, if you can think of being a videographer or a photographer and you have huge files that you're having to work with, a lot of times it would require you leaving it overnight just to upload everything so that you can actually get to work. Now all of a sudden with something like fiber technology, you can upload in minutes what you would have done in hours. So it gives you more time to actually work. It allows you to be more efficient with your time, and efficiency in business is key.
We believe in preparing our children to compete globally. So having the high-speed bandwidth will be a tremendous asset. So we can access instructors from around the world to bring in content that maybe we can't provide. We don't have the expertise here to provide. But also we're thinking about being able to have students who are interested in entrepreneur kind of work to be able to start their businesses while in high school with us and to utilize that high speed to advance whatever it is that they want to do for their future.
So what happens when you deploy high-speed fiber to a municipal institution like a school? Or how about 50 schools?
We have basically a gig fiber to each building right now, although we throttle that back because we only have 1 gig to the internet that's shared. But we do see that the 1 gig shared internet pipe is being maxed out quite a bit nowadays. So we definitely need to offload that bandwidth load off of our wide area network and off of that single pipe to the internet. There's just so many more applications these days that run directly out to the internet, out to the cloud, not like the old days where we had central servers maybe either at the building where they're just riding on the local area network, or even now we do have some centralized servers, maybe they're virtualized, but still there's an awful lot of applications that they're using out in the schools that are instructional software that's just straight out to the internet. Right now, it's really a pretty simple solution in that we have one filter. Filters all 20,000 computers, tablets, laptops that we have throughout the district in over 50 buildings through that one filter. But now we're going to actually have to have 50 or so individual firewalls. We'll have to have filtering for each of those individual buildings. And that's the challenge. You can buy relatively inexpensive firewalls and even filtering devices to handle low bandwidth needs, but once you start getting into that gig plus, it becomes a lot more pricey. And so that's kind of the challenge there, is that we're trying to fully utilize all of that bandwidth that they'll be bringing in at the same time that we're trying to protect those 50 locations and thousands of machines, and then also content filter to protect the kids as well.
If high-speed broadband has so many benefits, why isn't the rest of the country connected by fiber?
We always knew, different than some kinds of other economic development, we always knew that for this infrastructure to really deliver, more cities have to get online. In fact, we all need to be online. I mean, that's what the real promise of ultra-high-speed connectivity is. It's not just one city having it. In fact, if only one city had it, it probably wouldn't be a great thing.
If it were a question of mere funds, some have estimated that it would take somewhere between $200 and $400 billion to fiber the entire country if we wanted to do that. That's not going to happen. You know, we are in an environment in which we're talking about bringing deficits down, and we do not have a national consensus on the need for fiber to every facility, and that even if we did have that consensus, we don't have a consensus to spend $300 billion on doing that. So that's not, as a practical matter, going to happen, even if it were desirable.
Many believe that government policy stands in the way of innovation. Broadband adoption and penetration are not immune to this theory.
The FCC went out and did a national broadband plan, and in their broadband mapping, which was based on 3 megabits downstream and 768 kilobits upstream, so very, very low speeds, they found that there were 19 million people in America that didn't have broadband access. So large unserved area. Now the Connect America Fund is trying to take that universal fund, so that little about 14% tax you get on your phone bill, and try to redirect that into being able to get more broadband out to more people. And those standards are 4 megabits downstream and 1 megabit upstream. So if you look at that standard, there's even more millions of people that don't have broadband.
The whole idea behind CAF funding was to really allow carriers, the small rural carriers and some of these medium-sized carriers, to roll out broadband in a much more accelerated fashion. And unfortunately, because of some angst about how the rules have come out and maybe some delay in how the rules have come out, it's probably had the exact opposite impact.
There's a lot of money that the large carriers have chosen not to use, in part because the program is cumbersome, and if you're a larger carrier and you don't really need the support, you're choosing to not jump all through the hoops and barriers that are out there. The downside of that is that the customers that reside in those rural or high-cost areas served by those large carriers aren't getting broadband.
What we saw last year in 2012, that 63% of the money that Congress appropriated USF for these broadband funds were not used. And so what we're trying to do is to work on those rules with the FCC to be able to unleash this money that is available and be able to get broadband out to everybody.
What the FCC has done with this USF reform is they have not created incentives for more broadband deployment. In reality, they have, the large companies aren't using the fund to build broadband. The mid-sized carriers are basically just chasing themselves, trying to figure out what they're going to do next. And my carriers have certainly seen a disincentive. So I think all in all, at the end of the day, I worry a little bit about what the regulatory policy has done in terms of really inciting broadband deployment.
Still, some disagree about deploying high-speed broadband to rural areas. Is fiber the answer?
If you're really dedicated to bringing broadband services to rural America, building out fiber to the home is probably not, going to make an economic payback that's feasible to do that.
The fact that we have different topologies, different geographies, makes our networks and our broadband penetration rates somewhat more challenging than those that have really high densities.
And then you have an economic component. So if you look at, we would love to be able to get fiber all the way to a home or presence or business or a community anchor institution, but the closer you get to that business or home, the costs go up exponentially.
Building out fiber is obviously an expensive proposition. You've got to put together a business model to do it. So we've got a lot of challenges in terms of how can these small carriers continue to evolve and continue to build their networks, but still be able to do some cost recovery.
The U.S. pales in comparison to other leading countries in the race for broadband penetration. So how could the innovator of the Internet be so far behind?
When you see charts that say the U.S. has this average bandwidth number, and it's relatively low compared to the rest of the world, you have to keep in mind that the rest of the world built their systems out later than we built our systems out. So we're dealing with a legacy issue to a certain extent. But the market is fixing itself.
South Korea has the gold standard. And I'm not sure America, as vast as it is, with as diverse population densities as we have, that might be too fast for a national plan, but I think somewhere like that 7.4, that's probably the sweet spot.
With LTE deployed and ubiquitous across the U.S.'s capability to have a high-speed access connection will be on par with others around the world. Okay? And clearly it will grow. Companies like ours have also committed on the wired side to take a broadband capability using IP technologies as well to be able to drive a similar type of a service on the wired side.
The insatiable need for broadband may seem like a novelty, but it has a long and colorful history.
There was a huge amount of fiber and infrastructure built in the late 90s and into the early 2000s, just before the dot-com bust happened. So suddenly you have companies that were kind of selling this and pitching this going out of business. The demand for it dropped, and there was what was called dark fiber. The second thing that occurred as a result of that demand was, well, what if we take these expensive computers that we have in our data center here and move them off-site so that we don't have to maintain them, someone else can do that. That further reduced the cost for the business and allowed them, once again, to reach out in need of even higher bandwidth. Because if all of your servers are off-site and you're pulling back and forth with them, and you have satellite offices in other countries that also need to communicate with that server, suddenly you need a huge amount of bandwidth. And when there's demand, you'll get people who will supply it.
When I look back 4 years at where we were as a country, then so many Americans didn't even have a conception of what broadband was. And those who talked about broadband were talking in Latin, right? Now the language of broadband is colloquial. Everybody gets that.
With the emergence of modern smartphones, the industry transitioned from mainly wireline to one that is heavily invested in both wireline and radio spectrum. So what is radio spectrum and where does it come from?
The history of radio spectrum is as old as the galaxy, because sometime around the Big Bang, you know, we got all of this particular quality that is the electromagnetic spectrum, and it's a fascinating, amazing thing. I mean, if you think about it, you send a radio message into space, and it'll eventually get to the end of the universe. That's an incredible property. So let's kind of fast forward to the 50s, and you basically assigned a radio or a television station license in a beauty contest. People went before the FCC and they said, we're the best person to have the license because we'll do all of these things in the public interest, X, Y, and Z, and that's how they gave away radio licenses. When we get to the cell phone era, the first thing that they did was, how do we manage the cell phone licenses? How do we manage the spectrum of the radio frequency fairly? And they did it by lottery. And so you had people like McCaw and all these people, they went all over America figuring out where the cell phone sites were, and they went in a lottery. And basically it was luck. And if you were lucky enough to get, 10 cell phone sites in New York City, all of a sudden you had a valuable commodity. And then, the people were going, well, wait a second, why are we doing it this way? Why don't the American people get some of this cash? And that's when they came up with the idea that they would auction the airwaves.
The spectrum crunch, a shortage of available spectrum that once seemed like a doomsday scenario, has now spurred new technologies that industry is only beginning to use. To help solve this shortage in the U.S., the FCC is overseeing a voluntary incentive auction of underutilized spectrum from over-the-air television broadcasters.
Even if we could find all of that spectrum today, it would still take the better part of a decade before that spectrum would be felt by consumers. So here at the Commission, we have to put out for public notice and comment a band plan and auction rules, have the auction, have the checks clear from the winning bidders, clear the spectrum of current users, and then the network operators have to build out their networks and light it up for consumers. That's the better part of a decade. So what do you do in the meantime? So what do we do in the meantime is I think we have to, at a minimum, talk about and help encourage spectral efficiency. And there's one theory out there that says spectrum crunches actually help spur investment and innovation. So whether it's smart antenna technology, distributed antenna systems, cognitive radio, things like that, femtocells, picocells, things like that, getting that wireless signal to a piece of fiber as quickly as possible, or whatever the case might be. I think you'll see a lot of investment and innovation there because there's no other alternative. So it's sort of like building taller buildings in downtown Manhattan to make more efficient use of the land. So we're just going to have to figure out how to be more efficient with our use of the spectrum.
About 75% per year growth over each of the next 5 years. There's only one thing that's going to slow that down, and that's availability of wireless spectrum. And so the government is on this. I think they're doing all they can to try to free up government spectrum. But our challenge to everybody that's a participant in this is to let's make sure we're putting to work the spectrum that's in the marketplace today.
You need to continue to look for ways in which you can grow spectrum by working with companies either collaboratively or through M&A activity to try to gain additional spectrum. But we will clearly play in the large spectrum bids coming forward.
The biggest public works project since the interstate highway system has a $7 billion price tag. The public safety network poses the ultimate test.
Why isn't there already an interoperable public safety broadband network? Why isn't there a network where firefighters can communicate with the police if they're inside a building?
You're going to not be able to develop a new network from scratch for $7 billion. You're going to have to take advantage of existing infrastructure. You're also going to have to develop new infrastructure in some places.
My biggest hope in that regard is that what they will do when they look at pulling that network together is that they will look at where the existing infrastructure is and choose to use that $7 billion, which is a very small amount of money and that frankly has to come from future spectrum auctions, that they will use it to really build into those areas that you can absolutely not build a business case into building out to.
Broadband, I think, is a watershed moment in the future of public safety. The capacity, the capability that it has the potential to unearth to make first responders safer, more situationally aware, more efficient, and more effective. I think that provided the tipping point that said, okay, here's the reason to actually invest heavily, allocate spectrum for, and then start to drive a homogeneous network across the nation. The confluence of broadband and what it brings, along with this need to sort through the interoperability issues. I think that's what brought us where we are, and it just takes a while to work through the policy issues and the funding issues and all those sorts of things.
The market is pulling hard as demand for faster speeds and more capacity increases every day. It's up to industry to take infrastructure support to critical levels.
We've been looking at what can we do to get to ever increase speeds from whatever media we use, whether it be fiber or copper. And so one of the things that we did is we saw that as on the copper plant, we keep shortening the loops. Typically we can get 100 megabit per pair on VDSL, and so we looked at what technology would come after VDSL if we can shorten the loops even shorter and offer higher speeds.
When you're rolling out broadband in the wire center and ultimately you want to get it to the consumer, there's a lot of pieces involved in getting that product, that service delivered to the customer. Of course, in the central office is where it all begins. And in that central office you have aggregation equipment that combines both copper and fiber optic type products. And as they leave the central office, typically, traditionally, they roll out over these large cable binders that go north, south, east, and west in the wire center. And at the Ethernet layer, you can separate traffic logically. You can prioritize traffic so that you can use the same infrastructure to segment business customers and residential customers all over the same piece of of hardware equipment in the aggregation at the central office. You can do that in the optical space as well with different wavelengths to separate one customer's traffic from another, even though it's riding over the exact same fiber. These are the types of techniques that are used at the service provider to be able to really roll out and deploy and administer and maintain those broadband networks.
So now carriers are able to go out and deploy over their existing copper infrastructure new types of equipment that will actually get them in excess of 80 to 100 megabits when you're talking about bonded pairs. And that has really changed the game, and I think changed the economics.
We live in the age of high-tech consumer devices like tablets and smartphones. So why can't we have gigabit speeds to our wireless devices?
The wireless architectures have changed, and they've gone from GSM to HSPA plus and now LTE. And to enable higher bandwidth speeds, probably the consumer's a little bit sketchy about how much improvement is really there. So it'll take a little time before the mobile broadband experience will be able to equate to the wireline experience that consumers are very familiar with.
The wireless guys are trying to offload that traffic onto a fixed line network as quick as they possibly can and free up that spectrum. So that spectrum, they can reuse it over and over again.
Your wireless phone call, your wireless text, it travels most of its time on a wire, whether it's a fiber optic wire or a cable or the old twisted pair. And so, you know, in some ways, the whole trick on the cell phone game is to get your call as quickly as possible to the wire. So yeah, so these femtocells and other, you know, micro cell technologies improve that because it shortens the distance from your phone to the point where you can put that stuff into the backbone network.
What is the future of high-speed broadband? Is the demand real? Are the opportunities fair? Who will be left in the game when the dust settles?
Let's close the digital divide. There's 100 million people who don't have this at home. It's unacceptable that disproportionately those are low-income and minority Americans. And let's all come to the table and commit to making this happen.
We run the risk of getting into a mode where we're perpetually behind. I don't know if it'll necessarily mean, you know, the economic demise of the U.S., but I think this issue of, you know, do you want to be forever behind everybody else, especially with the technology that you actually invented?
It's not about internet connectivity. It's not about broadband for the sake of broadband. It's about the infrastructure that supports the applications that are going to allow a community to thrive.
The handicap of distance, capital, and access will play a role in the future of broadband. Some of us will get high-speed internet sooner and faster, while others may miss valuable opportunities due to geography, topography, and socioeconomics. What we know for sure is that the demand for broadband is real. It's now, and it's the bedrock for the future of the network. Stay tuned for Part 3 of TIA's Future of the Network documentary titled Break the Restraints, Uncovering Software-Defined Networking, coming to TIA2013.org on September 10th.